So the multiplication rule says if a certain task, we'll call it task 1, can be completed in m ways, a certain task, let's just call it task 2, can be completed in n ways, then together the tasks 1 and 2 can be completed in m times n ways. That is the multiplication rule. Now, here is the first application of the multiplication rule. You're required to take 5 courses, 1 each in humanities, sociology, science, math, and music. Now, for each type, we have choices. We have 4 humanities courses, 3 sociology, 5 science, and 2 math courses, and 3 music courses. How many different sets of 5 courses are possible? So we have to take humanities, and we need to take sociology course. We need to take a science course. We need to take a math course, and we need to take a music course. So we need to fill out 1, 2, 3, 4, 5 blanks. Now let's think about how many ways can each of these blanks be filled. So how many ways can we fill the first blank, which is humanities? There are 4 choices, so it can be filled in 4 different ways. The second blank, which is the sociology, we have 3 choices, so it can be filled in 3 ways. The next one is science. There are 5 choices of science classes. It can be filled in 5 ways. This blank is for math. There are 2 possible math classes. It can be filled in 2 ways. And the number of choices for music is 3. That is 3 different classes. So every blank has to be filled. So that way we have taken 5 different classes in each type. So this is basically an extension of the multiplication principle. If the first task can be completed in 4 ways, if the second task can be completed in 3 ways, and if the third task can be completed in 5 ways, if the fourth task can be completed in 2 ways, and the fifth task can be completed in 3 ways, all tasks have to be completed. So therefore, the number of ways in which we complete all the tasks is by using the multiplication principle. We multiply all the numbers to get 360. So there are 360 different sets of 5 courses that are possible. Now, 4-digit pins is just another example of the multiplication principle. If there are no restrictions, how many 4-digit pins are possible? So a 4-digit pin looks like 1, 2, 3, 4. It could be anything. For example, it can be 0, 0, 0, 0. That's a possibility because there are no restrictions. So it can be 1, 1, 2, 2, or it can be 3, 3, 3, 3. So your 4-digit pin, we always select these 4-digit pins for ATM and other things, can be anything. How many possible 4-digit pins do we have? So basically, forming a 4-digit pin is like filling 4 different blanks. All blanks have to be filled in order to complete the pin. So we have the first blank. How many ways can we fill out the first blank? We can fill it out in 10 ways because it can be filled with any one of the 10 digits. The second blank can be filled with any one of the 10 digits. Same thing with the third and the fourth blanks. So each blank can be filled with any one of the 10 digits. But the first blank and the second blank and the third blank and the fourth blank have to be filled. So here, the task of filling the first blank can be done in 10 ways. The task of filling the second blank can be done in 10 ways. The task of filling the third and the fourth blank each can be done in 10 ways. So together, all 4 blanks can be filled in 10 times 10 times 10 times 10 possible ways, which is 10,000 ways. So if you had a PIN number for your ATM machine, 1345, for example, and if someone was trying to guess your four-digit PIN, they would have to go through a maximum of 10,000 numbers in order to figure out what your four-digit PIN is. Now let's look at the next um, section of this worksheet. There are three types of probabilities. We've seen that there's theoretical probability, which is basically where we use our logic to figure out the quantitative values of probability. There's empirical probability, where we um, calculate probability based on experimental results or data collected. And subjective probability. Subjective probability is not scientific. It's based on experience and intuition. Like, for example, I can say, I think 25% of my class is going to get A's. So that is basically an educated guess from past experience. So that is subjective probability. Now, one important way of calculating probability is by using um, the rule, which is called the rule of complementation. So if suppose I know the probability of an event um, A happening. So what I know is probability of A. Suppose I know what it is. Okay. Now, and I'm trying to figure out what is the probability of A not happening. So what is the probability of not A? The event of A not happening is the exact opposite of the event A happening. So, for example, if I say it is going to rain tomorrow, the exact opposite of that would be it is not going to rain tomorrow. So, if I want to calculate the probability of the event that's the exact opposite of the other, then I use the rule of complementation. So probability that A does not happen is equal to 1 minus probability that A actually happens. So this is a simple rule, but we need to be careful when we use it, because thinking about what's the opposite or the negation of a certain event um, has to be thought through very carefully. So let's look at an example. We have problem 3, which says find the probability of drawing a black card out of the standard deck of cards. A standard deck of cards contains 52 cards. There are 13 of each. There are 13 hearts. There are 13 diamonds. There are 13 um, spades, and there are 13 clubs. These two are black and these two are red cards. So 13 of each, but then 26 black and 26 red cards. So what is the probability of getting a club or a spade would be getting black card. So the number of ways of getting clubs or spades is 26. You know, half the deck is either clubs or spades, and the total number of cards is 52. So the probability of getting clubs or spades is 26 over 52, which is really equal to half. That's the probability. So here again, we're applying theoretical probabilities of experiments with equally likely outcomes. What is the probability of randomly meeting someone born in April or October? Assume that there are 365 days in a year. There are 30 days in April and 31 days in October, so the total number of days in April or October is 61. The probability of meeting a person born in April or October. So out of the total number of days, which is 365, 61 of those days are possibilities of um, someone being born in either April or October. So 61 over 365 is the probability that someone is born in either April or October. So a probability is always a ratio or a fraction. It's something over something. The denominator is always larger than the numerator because this would have to be less than or equal to 1. And of course, the numerator could be equal to the denominator when it's a certain event. Looking at the next example, it says find the probability. Remember that probability is a ratio, it's a fraction of randomly meeting someone whose social security number starts with a 1 or a 0. So let's see what a social security number looks like. It looks like 3 digits, then 2, and then 4 more. So it's a total of 9 uh, numbers. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. Let's assume that social security numbers could even look like this: 0, 0, 0, 0, 0, 0, 0, 0. So there are absolutely no restrictions. Let's just assume that. Each blank can be filled by any of the 10 digits, starting from 0, ending with 9. So that is 0 through 9. There are 10 digits. Now, if the first blank can be filled in 10 ways, second blank in 10 ways, the third blank in 10 ways, and so on, and the ninth blank in 10 ways, then all the blanks simultaneously, when they are filled, they form social security numbers. Now we can fill all the blanks in 10 times 10 times 10 times 10 and so on. And what we're applying here is an extended multiplication rule. So all the blanks together can be filled in 10 to the 9 possible ways. So that is the total number of possible social security numbers. Now, how many of these 10 to the 9 numbers would have um, either 0 or 1 as the first numbers? So a social security number again can be formed by 9 digits. Now, the restriction here is in the first blank. The first blank can only be filled by 0 or 1. So there are 2 ways in which we can fill the first blank. Now, there are no restrictions as to what numbers or digits can fill the last 8 blanks. So the last 8 blanks each can be filled in 10 possible ways. So we have 2 ways of filling the first blank and 10 ways each of filling each of the other blanks. So using the multiplication principle, the number of ways of filling every single blank so that the number starts with a 0 or a 1 is 2 times 10 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 times 10. So that's the multiplication rule if all blanks have to be filled. So that is 2 times 10 to the 8th power. Now we're trying to find the probability. It's not just counting the number of ways of filling the blanks, but the probability that if we randomly meet someone, their social security number will begin with a 1 or 0. So the probability calculation is the last step. So the probability of the event of interest, that is meeting someone with social security number starting with 1 or 0, is a ratio. A probability is always a ratio. The total number of ways in which we can fill out all the blanks without restriction is 10 to the 9. The total number of ways in which we can fill the blanks with starting with a 1 or a 2 is 2 times 10 to the 8th, which is a smaller number. When we figure out the ratio, it's equal to 1/5. So the probability is equal to 1/5. Now look at the next problem. Find the probability, again it's a probability, of selecting a 3-child family with exactly two girl children. So again, we need to think in three steps. What's the total number of possibilities of um, a three-child family? So when I say what are possibilities, it's like listing something. For example, boy, boy, girl. That's a possibility, but that's not the only one. You have many other possibilities, like, for example, girl, 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 and so on. So instead of listing all possibilities, let's do it using the counting principle or the multiplication rule. We have three blanks to fill. Each blank is a child in the three-child family. The first blank can be filled by boy or girl, which means the first child can be boy or girl. The second blank can be filled with boy or girl. Second child can be boy or girl. And the third blank can be boy or girl. So there are two ways of filling each blank, and three-child family is complete only after you fill every single blank, that is, each of the three blanks. So the first blank can be filled in two ways, and the second blank in two ways, and the third blank in two ways. So the total number of ways of filling out all three blanks is 8, which is the same as saying the total number of possibilities in a three-child family is 2 times 2 times 2, which is equal to 8. That's our first step, figuring out the total number of possibilities. Our second step is to figure out the possibilities in which we have exactly two girl children. Now, this would be easy to list. It could be girl, girl, boy, girl, boy, girl, boy, girl, girl. So that is a total of three possibilities. Now, the last step is to figure out the probability that there are exactly two girls in the three-child family. So, probability is always a ratio. In the numerator, we have the number of ways in which the actual event that we're interested in can happen. So the total number of ways in which we can have two girls in the three-child family is 3, divided by the total. The bottom always has the total without restriction. Here it is with the restriction of two girls. So 3 over 8 is the probability of exactly having two girls.